Okay, so in the today's class we are going to discuss. Hello, hello. In today's class we are going to discuss regarding the angular gauges as well as the optical instrument for the angular measurements and autocalorimeter. So see, this all the measurements of a sine bar, sine center, angular gauge, uh, as well as the optical instrument for the angular measurements and autocalorimeter. So these all are the angular measuring instruments. Okay, by this you can measure the different types of objectives, angles. Okay, so in this last three uh, these concepts are remained, that is an angular gauge. Okay, the theory parts I have already explained, and now we'll see the some of the few problems of the by the angular gauge and autocalorimeter and optical instrument. Okay, so I would like to share the screen over here. Now you can see over here, in the previous class I have shown the set of an angular gauge set. So in this angular gauge set, there are three different types of slip gauges are there, which are in the angular shape. So which are the three different types of gauges? One is in the degree form, okay, and another in the minutes and the fraction. So see, when you tell the time, how you are going to discuss tell the time, uh, 1 hour. Okay, if it is on 1 hour 10 minutes and 30 seconds, like this way in the degrees also, degree, minutes and the fractions are been count during the calculation of the degrees. Okay, now let us see the how you are going to identify the degrees by the slip gauges. Now you can see in this above diagram over here, there are the two slip gauges are there, additional and subtractional. So see how the additional and the subtractions of a degrees are been count. So see, if it is an 27 degree over here they have given, so how we are going to find the 36 degree? So they are telling that to calculate the 36 degree. Now they are telling that to find the 36 degree. Okay, so this is a 36 degree you have to calculate. Okay, so by the help of this slip gauges. Okay, in this set, in this, so in this set, okay, there are three, this one they have given, okay, degrees: 1, 3, 9 and 27. So these are the set in which the standard slip gauges are there, and 41, 1, 3, 9, 27 and 41. So these are the degree angle slip gauge: 1, 3, 9, 27 and 41. Now by taking the help of this slip gauge you have to find out the 36 degree. Okay, so 36 degree you have to find out. So how you are going to find out? 27 plus 9 is equal to 36. Now see, the slip gauge is placed in this manner, that is a 27, then above the 27 the 9 is being kept. So this is how you will get the angle. Okay, this is how you get the angle of 36. Can you see the notes on your screen? Please reply. Can you see the notes on the screen? Huh? You can see, no? See, okay. So this is an angular gauge. Okay, so how you are going to find out the 36 degree over here? Okay. Now this is an additional method of getting the angle, or you are going to find the angle of the 36 degree. Now you can say angle of subtraction. Okay, 27 and 19. You have to get the 18 degree over here. You have to find out the 18 degree. So how you are going to find out? Okay, so see, 27 minus 9. 27 minus 9 is equal to 18. Okay, so during this you get the 18. Now see the position of the slip over here. In both the diagram you can see, I will, in both the diagram you can see the additional and the angle of additional and angle of subtraction. You can see in both the diagram the position of the ninth slip, how it is. Okay, so the conical part is in this direction for the additional, and the conical part in is it in this direction. Okay, for the additional it is in an opposite directional. Okay, and for the subtraction it is also in an inclined direction. So this both the direction are changes. Okay, in same way, in the slip gauges. Okay, there are the symbols have been given. You can see over here, this is an greater symbol in this direction. If the V symbol is in this direction, this is called as a lesser than symbol. This is a greater symbol, that is for the, it is used, this symbol shows how the slip gauge is kept for the additional, and this symbol shows how the slip gauge is kept for the subtraction, that is for minusing the degree. Okay, or otherwise plus minus symbols are also been displayed. Plus minus symbol is also been displayed on the slip gauge. According to the slip symbol position, you have to adjust the slip gauge one above other for additional or subtraction of an angle. So this is how the angular slip gauge are been used for measuring the angles. Now let us see some problems related to this angular slip gauge by using this slip gauge. Now you can see the numerical problems on building the angles. Building the angles means what? One above the other. You have to join the slip gauge by the Wheeling phenomena. Just in the previous class I have told how the Wheeling phenomena are being used for making the uh, joining the slip gauge to one other. Okay, now you can see over here, these are the following example for building. So now over here they have given 37 degree 9 minutes and 18 seconds. 37 degree 9 minutes 18 seconds. So you have to build up 37 degree as well as the 9 seconds and the 18 seconds. Now let us see the 37 degree how it is been built. So over here you can see, in this diagram, 27 plus 9 plus 1, that is, you can get the 37 degree. Now 9 minutes, for the 9 minutes a single 9 slip gauge is been kept. Then for the 18 second, 18 second, direct 18 slip gauge is there which has been kept. Okay, then you will get the angle of 37. Now you will get the angle of 37 degree 9 minute 18 second. Okay, so this is how you are going to build up the angular gauges to get the to build up the slip gauges. And get the angle. Now in the second example you can see, so see these are the standard slip gauge with the standard number. With that standard numbers only you have to do the build up the angles or subtract the angle, plus or minus you have to do. Okay, same numbers slip gauges are been there, different numbers are not there. Okay, within that same standard numbers are there in that slip gauge set. With that standard numbers only you have to adjust the position of the slip gauge, plus or minus, subtract or additional for getting that particular angle. Now you will see the subtraction and the additional of the slip gauge. Now you can see over here 33 degree 16 minutes and 42 seconds are there. Okay, so you have to make the angle of this by using the slip gauge. Okay, now 33 degree you are going to find out over here. So this is the problem. First in the 37 degree was there, now 33 degree. Now what you are going to do, 27 27 add, so see the symbol V symbol over here, 27 plus 9. Okay, how much it is, 27 plus 9, 37. Now you have to minus from this 3, so you will get 33 degree over here. So you will minus the 3, you will get 33 degree. Okay, now 33 degree is finished. Now you have to go for the minute. For minute 27, now see the symbol in less than direction it is, that is a minus direction. 9, 27 minus 9, how much it is, it will be near about 12. Okay, sorry, 15, 15 minus 3, uh, sorry, 27 minus 9, 8 minus 3, see, 27 minus 9, 18, 27 minus 9, 18, 18 minus 3, 18 minus 3, how much, 8 minus 3, 15. Okay, so now it is 15, then you have to add one slip. Okay, now over here 9, 27 minus 9, 9 minus is equal to 18, 18 minus uh, 3 is equal to 15. Okay, now you want in 16 minutes, so plus 1, that is an 16. Like this way you have to interchange the slip. If it is additional, change the position of the slip. Okay, if it is an plus, go for the greater side of the slip. Okay, like this way, by adjusting the slip, by taking that particular slip from that particular set. Okay, the standard numbers are there, according to that number only, just like a puzzle, according to that number only you have to plus, subtract or minus to achieve that particular degrees. Okay, then the second same way to find out the friction, that is a 42. Okay, same 0.5 plus the, you are taking a first slip. Okay, that is 30 degree you have taken, then 30 degree plus 18, sorry, 30 second plus 18. Okay, then minus 6, you will get the 42 degree, sorry, 42 seconds, 42 seconds. So like this way, by adjusting the slips, you can get 37, 16 and 42, 37 degree, 16 minutes and 42 seconds angle over here. Okay, that is a theta angle. So like this way the angular measurements, sorry, like this way the angular measurements are being identified and get by the different types of this angular gauges. Okay, now over here you can see there is a square slip gauges are there of degrees by which you can get the above 90 degree angles. Now you can see how it has been find. Now 102 degree 8 seconds and 42, sorry, 102 degree 8 minutes and 42 seconds you have to find out. Now you can take the square 90 degree slip gauge or the angular gauge over here. For that 90 degree plus 90 degree plus 9, okay, then the angular gauge is been used. Okay, now you can see over here in this slip gauge set there are square gauges are also there. Okay, of square gauges which gives the 90-degree angle, that is a perpendicular angle. 90 degree taken, 90 plus 9, 99 plus 3, 102, you get the degree over here 102. Okay, at this slip gauge you got the 102 degree over here. Now you are going to add for the degree more for the minutes and the second, that is an 8 minutes. For 8 minutes a ninth degree is been added. Okay, from that 9 degree 1 degree of a slip gauge is been minus, then sorry, not in degree, sorry, not in degree, minute slip gauge you have taken 9 minute, first slip gauge you have taken, so this is a 9 minute slip gauge is there. From this 1 minute is been minus from that particular slip gauge, so 8 degree you will get. Okay, then next seconds. Okay, now you are going to find out the seconds. Now take the second set of the slip gauge, that is an 30 plus 18 minus 6. Okay, so 30 plus 18 is 48, 48 minus 6 you will get 42. So like this way from over here to here, from this to this you will get 102 degree 8 minute and 42 seconds. So like this way you have to identify it by using the different angular gauges, that is for the minute it is different, for the second it is different, for angular it is different. From the angular angle set or the degree set you have to take the degree slip gauge. For making an for making in minutes you have to take the minute set, okay, often slip gauges. Then for the second, for the seconds the different slip gauges are there, you have to take the angular slip gauge of the seconds for additional for making an angle. Okay, according to the numbers on the slip gauges, okay, you have to adjust the additional or the subtractions for getting that particular degree, okay, in minutes, seconds or in a degree. So like this way these are the few problems on the angular surface gauge you have to follow and go through this. Okay, I have already shared the notes. Okay, by this notes, go through the notes and try to solve more and more problems by this uh, of this angular slip gauge. Now we'll go with the concepts with an autocalorimeter. Okay, so the which is used for measuring the straightness of the squareness and as well as the angles. Okay, so I will share the screen. These are the some of the screenshot of the diagram. Can you see on the screen the some autocalorimeter diagram? Can you see on the screen? Hello, please reply. Can you all hear my voice? Hello, my voice is audible. Okay, so see the autocalorimeter, which is an instrument, okay, which is used in the metrological lab for measuring the angles of and components, okay, or the mechanical instruments. Autocalorimeter, it is an optical instrument used for the measurements of the small angles and its differences. Okay, optical instrument means what? It works on the optical lenses. Okay, different types of lenses are there on which basis the rays are being transferred. On that rays, we'll see. I will show you the principle on how the optocolorimeter works. Okay, but it is an works on the lenses on the light rays for the measuring of and different uh, lights, as well as the angles, straight lines and the perpendicular degrees. Okay, it provides a very small, sensitive and accurate approach of an angle, very sensitive, a small workpiece angles, okay, and give the accurate approach. Okay, by this autocalorimeter, small angles of the small objectives can be measured. It is essentially required in telescope calorimeter combines with a small. Okay, so by the help of a telescope, some of the angles of a small projects are been find out. Okay, can be get accurately. So in this autocalorimeter, we are going to study on what working principle it works. Okay, on what working principle it works, constructions. Okay, what are the different parts are there in this autocalorimeter, as well as the working of this autocalorimeter and the uses. Okay, now see the principle on what basis the autocalorimeter works. Okay, so it is a light reflecting principle is there on which basis the autocalorimeter works. Okay, so this is what the simple diagram. So see, by with the help of this autocalorimeter, you can measure the perpendicular angle, that is an straightness as well as squareness of that particular project. If the project is in straight means what? It is having a 90-degree, as well as if it is having a 90-degree, so the square workpiece can also be measured. All the four sides are 90-degree, that means what? It is a square. To measure all the four sides by the help of this autocalorimeter, you can get the squareness of that particular project. So how the square and the angles are been identified? Okay, that you are going to that I will going to tell you that by this simple working principle. Now you can see over here. So over here there is a reflector is there, and this colorimeting lens is there, and over here this is an object, that is a workpiece is kept. From over here the light is been transferred through this reflector. Okay, so the different ways the light rays are coming, which are been concentrated on the single point over here. From this single point it is been sent to this lens. What this calorimetric lens do, collect the light and send the light into a parallel position. So now you can see parallel, they are not in an angular direction. The light rays are not in an angular direction, they are going in a parallel direction. Now what happens if the reflector, or sorry, you can tell is the reflector, or the object from where the light rays reflect back once again. When the light rays are been को इंसाइड टू दिस ऑब्जेक्टर, इस ऑब्जेक्ट को जब लाइट रेज आके डैश होते हैं, तब क्या होता है, यहां से लाइट रेज वापस रिटर्न बैक होते हैं. सो लाइट रेज आर बीन रिटर्निंग. Hello, hello, hello.